Video. It's everywhere, right? Central to how we get information, how we're entertained. But think about this. What if AI could go beyond just seeing what's in a video? What if it could truly understand the story, the why behind the action, especially in long videos? That's a whole different level. Today, we're doing a deep dive into exactly that, how some really cutting-edge AI is learning to reason through long stretches of video, kind of like we do.
Yeah, and our main source for this is a brand new research paper just out today, July 11th, 2025. It's called Scaling RL to Long Videos.
Yeah.
Comes from a pretty impressive team, too. NVIDIA, MIT, HKU, and UC Berkeley all collaborating.
Okay, so our mission today is to unpack their framework. It's called LongVideo R1. We want to figure out how it tackles these, well, really tricky challenges of understanding long videos.
And it's important, like you said, to distinguish this from just basic video recognition. We're talking about reasoning. That means understanding things over time. Spatial stuff, why characters or people are doing things, their goals, and following the actual plot or narrative. Think about, say, predicting who wins a penalty shootout in football. Not just seeing the kick, but maybe assessing player emotion, tactics, or tracking where a hidden ball ends up after a bunch of shuffles. That's way beyond simple object spotting.
Right. So why is that deeper reasoning, especially over long videos, so hard for current AI, for these vision language models or VLMs? The paper points out a couple of big things. First, just getting the right data is a massive challenge. Finding or creating data sets of long videos with really good annotations about reasoning. Annotating complex stuff like goals, spatial changes, narratives over minutes, maybe hours. That's tough, and it takes a lot of work.
It really does. And the second big thing is the computation. Applying techniques like reinforcement learning, RL, which you often need for this kind of complex learning, while doing that on potentially thousands of video frames, it just eats up memory and processing power like crazy. It's computationally very expensive.
So these two things, the data bottleneck and the computational cost, have really held back progress.
Exactly. And that's where this new framework, LongVideo R1, comes in. The researchers designed it specifically to, well, scale up reasoning for these long videos. It's built on three core pillars, basically. First, a big new data set. Second, a clever two-stage training process. And third, some specialized infrastructure to handle the heavy lifting during training.
Okay, let's take those one by one. First up, the data set. It's called LongVideo-Reason.
That's right. It's got 52,000 long video question-answer pairs. And the key is they have these high-quality reasoning annotations.
What kind of videos are we talking about?
Oh, it's pretty diverse. You've got sports clips, gameplay videos, vlogs, a good mix. And how they made it is interesting, too. They set up this automated pipeline. First, they chop the long videos into smaller bits, like around 10 seconds each. Then they use another powerful model, NVLA-8B, to generate captions for each of those short clips. Good descriptions.
Okay, so captions for the small chunks. Then what?
Then they bring in a top open source reasoning LLM. Its job is to look at all the captions for a whole video and generate questions that require reasoning across that entire duration. And not just any questions, but ones focused on different types of reasoning. Temporal, like when things happen, goal and purpose, why someone's doing something, spatial, where things are, and plot and narrative, understanding the story.
Wow, generating questions that require looking at the whole thing, that seems key.
It is. And to make sure the quality was high and the reasoning was genuinely challenging, they also manually checked and curated a smaller benchmark set about 1,000 samples called LongVideo-Reason-eval. It covers all four reasoning types.
And I saw something about how they filter the data using easy, medium, hard samples.
Yeah, that's part of their training strategy. They use the easy and hard stuff, about 18,000 examples for an initial fine-tuning stage. But the medium difficulty ones, which are still pretty challenging, about 33,000 of them, those are saved specifically for the reinforcement learning stage later on.
Okay, that makes sense. So that leads us to component two, the training pipeline itself. It's a two-stage process.
Correct. Stage one is called long CoT-SFT. That stands for Chain of Thought Supervised Fine-Tuning. Think of chain of thought like teaching the AI to show its work, to lay out the steps in its reasoning.
Ah, okay. Like explaining how it got the answer.
Exactly. So this first stage is like a warm-up. It uses those 18,000 easy and hard examples with detailed reasoning steps. It gets the model familiar with reasoning basics and following instructions. They use something called the MMSP system to help manage this phase efficiently.
So it learns the fundamentals, learns how to reason step by step, and then stage two ramps things up with reinforcement learning.
Precisely. Stage 2 uses RL, specifically an algorithm called GRPO, to really scale up the reasoning capabilities. GRPO is good for these big tasks because it helps keep the training stable while still being pretty efficient with the data. This is where they use those 33,000 medium difficulty samples from their own dataset, plus about 110,000 more samples from other existing datasets. The goal here is to guide the model towards developing more powerful and, importantly, more general reasoning strategies.
Okay, dataset training pipeline. That brings us to the third piece, the infrastructure. MRSP, multi-modal reinforcement sequence parallelism. Sounds complex. This is tackling that massive compute and memory problem we talked about earlier, right? How does it work?
Yeah, it's basically a really smart way to handle the sheer volume of video data during RL training. It works in two phases. First phase, rollout with parallel encoding. Imagine you have a long video. Instead of one GPU crunching through all the frames, they split the frames across multiple GPUs. Each GPU processes its own little slice in parallel.
Okay, divide and conquer.
Right. But here's the clever bit. Once those frames are encoded into embeddings, like numerical representations, they reuse those embeddings for multiple steps in the RL process. They don't have to keep recalculating them. That saves a ton of computation.
Reuse. Smart. Okay, what's the second phase?
Second phase is prefilling with sequence parallelism. After gathering those reusable embeddings, they partition them again across the GPUs. This lets each GPU handle just a part of the whole sequence during the really compute-heavy parts of the RL update for both the main model and its reference model. It basically keeps all the GPUs busy and maximizes efficiency.
So what does this mean in practice? Like, how much faster is it and what does it enable?
The benefits are pretty significant. They report up to a 2.1x speedup when training RL on videos with 512 frames. And maybe even more importantly, it lets them train on much, much longer videos, up to 1,024 frames, without hitting those memory walls that usually stop you.
What?
They even mention it can handle RL training on hour-long videos that's like 3,600 frames or 256,000 tokens on just a single standard AI server node, like one with A100 GPUs. That's a big deal for feasibility.
That really does sound like it breaks down a major barrier. Okay, so they built a data set, the training process, the efficient infrastructure. How well does LongVideo R1 actually perform?
The results look pretty strong. On general video understanding benchmarks, the LongVideo R1 model, the one trained with RL, consistently does better than the base LongVideo model without RL.
Okay, but how about on their own reasoning benchmark, that LongVideo-Reason-eval set?
That's where it really shines. The 7 billion parameter version, LongVideo R1 7B, gets an average accuracy of about 67.9%.
How does that stack up against others?
Well, it beats other open source models pretty handily, like Video R1 7B, which got around 62.7%. It even edges out some very powerful proprietary models. For instance, they compared it to GPT-4o, which scored 60.7% on this benchmark.
So better than GPT-4o on this specific long video reasoning task.
On this benchmark, yes. And it basically matches the performance of Gemini 1.5 Pro, which came in around 67.3%.
Interesting. Any particular areas where it stood out?
Yeah, particularly in spatial reasoning. LongVideo R1 got 70.0% accuracy there, while Gemini 1.5 Pro was at 63.2%. So a noticeable lead in understanding spatial relationships over time.
And does it handle longer videos better in practice?
That seems to be another key advantage. They showed that even a smaller 1.5 billion parameter version, LongVideo R1 1.5B, keeps improving its accuracy as you feed it more frames, getting up to 64.3% at 512 frames. A lot of other models tend to plateau or even get worse when the video gets that long and dense, so it seems to scale better.
Okay, numbers are one thing, but can we make this more concrete? You mentioned that football penalty shootout example earlier.
Right. That was a great illustration. LongVideo R1 didn't just see players in a ball. It seemed to analyze things like player body language, maybe their tactical positioning, maybe even inferring their emotional state to predict the shootout winner. Other models they tested apparently made wrong guesses or sometimes just made things up hallucinated. LongVideo R1 showed, well, a deeper level of interpretation.
And the hidden ball example, the spatial tracking.
Yeah, that one's really telling for spatial and temporal reasoning. It involved tracking a ball hidden under one of several boxes, and those boxes were swapped around quite a bit, deceptively. LongVideo R1 was able to follow the complex trajectory of the correct box and pinpoint the ball's final location accurately. Other models apparently got lost or were inconsistent.
It sounds like it's really connecting the dots over time. What about plot or narrative?
They had an example from something called a detector game. The model figured out why a man wasn't someone's husband by noticing he wasn't wearing a wedding ring. That's pretty nuanced reasoning from the absence of something.
Subtle cues.
Exactly. And another one involved Texas Hold'em poker, where it seemed to interpret betting patterns and implicit strategies to understand the game state. So putting it all together, LongVideo R1 really does seem like a significant advance. It combines that large reasoning-focused data set, the two-stage CoT and RL training, and that efficient MRSP infrastructure. It's pushing the boundaries of what VLMs can do with long-form video.
Though it's good they also mentioned the limitations. Like, the whole idea of reasoning itself probably needs more work, more precise definition,
Oh,
and they see room to get better at handling even longer, maybe ultra-dense videos, as they put it.
true. No research is ever the final word, but this definitely lays important groundwork. It's moving towards AI systems that can really understand sequences of events, track things over time, figure out cause and effect in visual data.
And you can see how that would be crucial for things like robotics or autonomous systems, right? An agent needs to understand context over time to plan and act safely.
Absolutely. Embodied AI, robotics, self-driving systems, they all need that kind of deep temporal understanding.
But also maybe areas like education. Imagine an AI tutor analyzing a long instructional video to see where a student might be struggling. Or in healthcare, reviewing lengthy procedural recordings.
Or even entertainment. Think about super detailed sports analytics based on hours of game footage. The potential applications are quite broad.
It really makes you wonder.
What insights might AI uncover from hours of visual data that we, with our limited attention, might miss entirely?